Okay, I want to do 3 questions from the assess right now. That's on page 17, but the questions I want to do on page 18. So page 18, question 10, currently grade B question, but let me just do it anyway. It says Rowan puts petrol in his car. Petrol costs 0.98 of a pound, in other words 98p a litre, I wish, and he pays £49.90. Let's just write down both the figures and then we'll do what we have to do with them. To fill the tank, how many litres does he buy? How accurate is your answer? Let's have a look. How many litres does he buy? So let's have a look. So I need to go £49.90 divided by my 0.98. Let's see how many litres that is. Obviously it's not quite a pound a litre, so 49.9, don't need a 0, divided by 0.98 equals 50.91836 litres. And let's see what the question actually asked me to do. How many litres does he buy? In terms of whole litres, well, it could be 50. In terms of rounding up, 51, there is whole number. A litre 1 decimal place. So he bought approximately 50.9 litres to 1 decimal place. It's not obvious what the question is requiring. How accurate is your answer? Well, I've made it accurate to 1 decimal place. Maybe I could go 2 decimal places because of the 2dp in the question. So I could say therefore 50.92 litres to 2 decimal places, because obviously the 8 will push the 1 up to 92. So 50.92 litres to 2 decimal places, that's the level of accuracy that I've chosen. And that is easy. Now, next question is question 11, jumping straight into A star. Right, Lyra's height is 154 centimetres. So 154 centimetres, well 1.54 metres actually. This girl's called Lyra, and Louise, oh dear, they're both L's, let's write it out then. So Lyra and Louise, what's her deal? She's 1.61 metres, and both heights are measured to nearest centimetre. Lovely, okay, so let me just convert it all into centimetres to make life a little bit easier for the brain. Nearest centimetre, I can be half a centimetre either way from previous videos, so I can take away 0.5, so lower bound 153.5, upper bound 154.5. if I add on the half centimetre onto Lyra's height. Same thing with Louise, 160.5, taking away the half there, adding on the half, 161.5. and we're told what's the maximum possible difference between Lyra's height and Louise's height. Maximum possible difference. I'm only going to do what they want in the question. Maximum difference, well, we'll take the biggest one there for Louise and the smallest one there for Lyra, take it away and get our grade A. So here we go, maximum difference. It's going to be 161.5, take away 153.5, grab the machine, 161.5, take away 153.5, gives us 8. Well, the maximum difference between the heights is just 8 centimetres. Alright, that's that one. That was question 10. I've opted to do question 11 as well. Sorry, that was question 11. Question 14, A star, absolute killer. Lots and lots and lots to do for that one. You're going to have to follow this in the book, it's complicated. A factory makes ball bearings with a diameter of 4 millimeters. So here's a ball bearing, and the diameter through the centre, from there to there, is 4 millimeters. And it's correct the nearest millimetre. In other words, I can be as big as 4.5 or 3.5, depending on the storyline. So let's go 4.5 or 3.5. That'll be the upper bound, that'll be the lower bound. Alright, so I'll see what we need to use later on. They are spheres of stainless steel, okay, so they're ball bearings. The volume of stainless steel available to make these things is 500 425 cubic centimeters cubed of steel, and that's the nearest 5. Well, let's take it down a little bit. 5 to 2.5 minimum, or add on 2.5 because it's a spread of 5. 5 to 7.5. Okay, I added on 2.5 there, and I've subtracted not 0 please, and I subtracted 2.5 there. Alright, so as you can see, that is a range of 5, maximum possible error 2.5 each way, to leave that one right in the middle, which is what we want. Alright, so that's that. Now what's the story say? What is the minimum number of ball bearings that can be made? Alright, to get the minimum number of ball bearings that can be made, I need these little ball bearings to be as big as possible, and I need the volume of steel available to make ball bearings to be as small as possible. So I'm going to be using that figure, and I'm going to be using that figure somehow. Now we're told that the volume of a sphere is as follows: 4/3 times pi times the radius cubed. First time we've used it in this unit, therefore they had to tell us what the formula was. So let me work out the maximum volume of each ball bearing. So substituting 4 divided by 3 times, taking pi to be 3.14 traditionally, multiplied by the radius squared, the radius cubed. Now please note that is a diameter, therefore I need to divide that by 2. So 4.5 divided by 2 is going to be 2.25. So that's 2.25, that's the radius, half the diameter, and that has to be cubed. And let's get the answer for that. Right, so 4 divided by 3 times 3.14 times 2.25, and that's my cube button on there, equals, okay, each ball bearing has a volume of 47.6887 centimeters cubed of volume. Now I'm not going to round anything off just yet, alright? So that's the maximum possible size they can be. What is the minimum volume of steel? Well, the answer is 522.5, so that's going to be in millimeters cubed, isn't it? Sorry, not centimeters cubed, that's millimeters cubed. You have to convert these things. Right, now I'll be using that one in a minute. I need to convert millimeters cubed into centimeters cubed, so I can do a division sum between that one and that one, or I can convert these centimeters cubed into millimeters cubed. Now, I think I prefer to do it that way actually. So imagine this. Here is a little cube. If that is 1 centimeter across there, then we've actually got 10 millimeters. 10 millimeters there and a 10 millimeter height. Well, that gives us 1,000 millimeters cubed, and that makes 1 centimeter cubed, which is almost unthinkable. Just a little centimeter cube has 1,000 millimeter cubes in it. So I want to multiply this by 1,000 so that the units are comparable. So here I go, here's my next step. 522.5 multiplied by 1,000 is 5225, bounce over 3 times, 0 millimeters cubed of steel available. Just check that. 1, 2, 3, that's good. Now I can divide. I take this volume of steel available, minimum, and I divide it by the maximum possible volume of these bearings, ball bearings, 47.68875. Now let's see, do a division. 522,500 millimeters cubes of steel available. Divide that by 47.68875. That gives me 10,956.46 little ball bearings. In other words, in terms of whole numbers, 10,956 ball bearings. Is that alright? Now that's every little bit A star. Upper and lower bounds, a formula you've not used before, awkward numbers, mixed units. You really need to rerun this video about 15 times. And that's it. Thank you so much for watching. That is the end of chapter 1.